So I have to pick a 3-digit number that's divisible by 9 and 5. So that means that it could have a 0 or a 5 in the ones column, because that's what makes things divisible by 5. And then the total of all the digits has to equal 9. So I could put anything in the hundreds place or the tens place as long as all the digits end in 9 or 18, because that's divisible by 9 too. So I think I'm going to pick 3 in the hundreds place and 5 in the tens place, which means in order to add up to 9, I need to add a 1. So 315 is divisible by 9 and 5. So that's part A done. Part B, I have to find the factors of 315. I'm going to use the divisibility rules. Is it divisible by 1? Yes. All numbers are divisible by 1, and factors come in pairs, so 1 and 315. Is it divisible by 2? No, it's not an even number. It's not divisible by 2. Is it divisible by 3? Well, the digits add up to 9, so it's divisible by 3. 3 goes with 105, because factors come in pairs. Okay, is it divisible by 4? Well, the last 2 digits are not divisible by 4, so it's not divisible by 4. Is it divisible by 5? Yes. So 5's going to need a pair. So what are we going to have for 5? That's going to be 63. Okay, is it divisible by 6? No, it's not divisible by 2, so it can't be divisible by 6. Is it divisible by 8? No, it's not divisible by 4 or 2, so it can't be divisible by 8. It's divisible by 9, we know that already. So if it's got 9, it has to have another factor. So So 9 goes with 35. So that makes another pair of factors. There's a big gap between 9 and 35, so there might be other factors. It ends in 5, and 3 and 5 are both factors, so I bet 15, 3 times 5, is also a factor. And if 15 is a factor, it's got to have a partner. The 15's factor partner is 21, so 21's a factor. And that seems like that must be all of them. So there's my list of factors using the divisibility rules. Okay, so C says I have to pick the largest and smallest numbers. Well, I know that the largest number in the hundreds place will probably have 9. So that means in order to be divisible by 9 and 5, it's going to have to end in 5 or 0. So if it ends in 5, we'd have 945. If it ended in 0, we could have 990. 990 is bigger, so that's the biggest one. For the small numbers, again, in the 100s place, we could have a 1. And it would end in 0, or it could end in 5. If it ended in 0, it would have to be 180. If it ended in 5, it would have to be 135 to add up to 9. So 135 is the smallest. So there, I found the largest and the smallest 3-digit numbers that are divisible by both 5 and 9 using the divisibility rules.